Alright, our lesson today is on wall framing layout. So the first step in building your walls is to lay them out. So to start, walls are what make a structure a structure. It encloses it in. So right here we can see a couple. These are walls for houses. So walls can be solid like you see on the side with no openings, or they can have openings such as windows and doors. This is a pretty large opening right here, probably for a garage door. All right, the very first piece, all right, of the framing of a wall is your studs. And your studs are the vertical framing member that makes your wall a wall. And they usually are evenly spaced at 16 or 24 inches on center. The sole plate or bottom plate is what the 2x4s will be attached to. It's at the bottom here. And that's what holds all the studs together at the bottom. And then the top plate holds all the studs together at the top. So they're called plates. And all they are is the same 2x4 or 2x6 lumber, all right, but they're just laying down and then the studs attached to them. And then on top of the top plate is the double top plate. And that's what locks the walls together. You can see how this double top plate up here is lapping over right here. All right, so going off of the 2x4, 2x6 walls. So the reason why currently that we use 2x6 walls is because of the insulation. And so think of your house as almost like a Yeti water bottle. You want to keep whatever's in there the same temperature as you put it in for a long time. So that's what you want to do with your house. If it's summertime and it has cold air, you want to keep that cold air in your house and not have it escape. So that's why 2x6 walls are used for the exterior, because you can put more of this pink insulation is. And how that's relevant to this is because what you have to know whether you're laying out for a 2x6 wall or a 2x4. And for exterior, it's code now to use 2x6s. And you just get a lot more insulation, and it'll help keep the heat in your house and help keep the cold air in your house. All right. So now we have our window and door openings. So you have a door here, all right, and your window here. And what they both require is a header to carry on that load, because studs were really originally supposed to go here every 16 or 24 on center, but you have to have an open. You can't have any studs because it's an opening. All right, you can't walk through if there's a stud there. All right, so to carry that weight, you have a header. All right, where that dissipates that weight to the side here. All right, headers rest on the jack studs that are right here. So you can see the header here, and it's resting right on the jack stud. And then that's what carries the weight from the header. All right, and attached to the jack stud is the king stud. And here's the king stud right here. All right, and these are nailed together. And then the header is nailed in from the king stud right there. And the cripple studs carry on the on-center spacing that we have on our wall. So you imagine if this was just a regular wall with no windows, that these cripples would go all the way up and carry that on-center spacing. But this is open right here, but that spacing still needs to be carried. And that's kind of showing the weight of the gravity and weight of the house, all right, dissipating through the top plate to the header, going down the king and jack studs. All right, so this is a better picture of it. So you have your header up here, then you have your cripple studs carrying our on-center spacing, jack stud, and your king stud. All right, so windows can have top and bottom cripples, but doors do not have any bottom cripples because you wouldn't be able to walk through the door. You can see the window has a bottom cripple. All right. So this is like the entirety of it. So you start with your base plate, or your sole plate, or bottom plate. So you can say either. You just have a regular stud. Top plate is the first one, and then the double top goes on top. And then you have your headers carrying the load where above the openings, and then resting on the jack studs, and then the king studs close it in. And then for windows, you have another part called the rough sill. So that's kind of your window sill for your opening, and it's just made out of framing lumber, your rough sill. And then you have your cripple studs. All right, this is just showing how your double top plate comes in and locks in. All right, and it even locks in on interior partition walls. All right, so on a blueprint, when we're laying out, there's two different kind of walls, exterior. You either have a load-bearing wall or a non-load-bearing wall. So the load-bearing walls are on the exterior here, and they're carrying the weight from the roof. Now these ones, all right, are going to be made a little bit differently because they're carrying the weight, and they are the ones that are going to have your California corners. So if it's a load-bearing wall, you're going to have this California corner. And this is a way for you to tie in the walls together because they're going to be nailed from here, all right, in, and from here in. It also gives you a way to tie in your drywall, all right, on the inside. So this is how you make your corner. So this is your exterior load-bearing wall, and this is your exterior non-load-bearing wall coming in. So you can see here how this wall is butting up against the other, and that's into the load-bearing wall, and that's how it attaches. And this is also called an insulated corner because you can put insulation behind it. All right, this was the old way of doing it, and you really couldn't you would put a stud. All right, this is the load-bearing wall. You put a stud here, and a stud here, and then attach the wall here and here. But now, all right, with the new one, you can kind of tie in all that insulation in there. All right, or you could do a solid 4-stud corner, but that would be kind of a waste of time. All right, another way, this is how Larry Hahn likes to do it, is that you put all these blocking in to move out this stud, and you could do that, but that's just another way to make a corner. So we like the 3-stud corner. All right, so the on-center spacing for framing. The reason why we have 16 inches on or 24 inches on center is because all sheet goods, all right, are 48 inches, all right, wide by 96 inches long, and 16 and 24 break evenly in that on center spacing. So that's why we use 16 and 24. All right, so for our layout, X is where you lay out your studs, and then, so this is a little bit reversed, all right, but because we want to start on the left side, but this is kind of like a mirror image of it. All right, we want to pull 15 and a quarter from the end of our wall if we want it to be on center, because the 2x4 is 1.5 inches wide, so we go back 3/4 of an inch because 3/4 is half of 1.5. All right, and if we put the stud on the 15 and quarter line, the actual stud itself would be 16 on center, and that's why it's 15 and a quarter. So it's important to make sure that you put the X on the correct side, all right, because this is not the center of the stud. This is the edge of the stud. If we mark the actual center of the stud, you wouldn't even see the line, all right? So you can at least see the line, that's why you put the edge on it, all right? So you put it on the 15 and a quarter, and then it'll be centered at 16. All right. So for window and door openings, you do mark the exact center of the window and door. Like I have here, 36-inch window is centered on 48 inches. You would center it exactly on 48 inches, and then you would go 18 inches to the left and 18 inches to the right, because half of 36 is 18, so it would be split at that 48-inch mark. All right, you can see here that would be the center of an opening, and he measured here and then edge of the other rough opening. All right, that concludes wall layout. All right, it's important that when you lay out that you lay out both plates together, and that this is how you so you minimize mistakes. So you get your plates together, and then you'll be able to lay out.